It's a strong grip. Speed is what, per pick? I can't see the speed automotive on it. So before it was grabbing the toe, pushing the toe. And now if you look at how it's picking, it's much more subtle, even on the object itself.
Yeah.
Everybody is already using LLMs, chatbots, and etc. But robots, humanoids, it's really true AGI because they can do whatever you want and can imagine. We've built our own proprietary VLA model, Vision Language Action model, that help robots do different tasks in real world with human speed. And this is and also robot can learn new skills, new use case, just even in a couple of days. We just need to put a little bit additional data from this type of new use case, and robot can do whatever you can imagine. And this is a secret sauce.
Change what we're training on.
A lot of companies are building just hardware or just software or just AI models, and our advantage is that we build a full stack from hardware to AI models and also integration application layer, and we build really a final product. And our main advantage is that we are the youngest company in the field, but we are the fastest.
So you're basically doing some smoke testing before we merge this into a new branch and make a new release, or is this already on a release, or what?
Make it more reliable, more flexible, so that we can throw in an object in the scene. And
So these are wheeled humanoid robots that are targeting industrial use cases, so manufacturing, warehouses, logistics, automotive suppliers, etc. But we also have an alpha biped, so that's a robot with 2 legs, and this is rounding out our ability to address lots of different use cases inside of industrial facilities. And so these are prototype systems. Our production systems are coming later this year, and those are the ones that will ultimately get sold to end customers and deployed in these facilities.
where we release the latest version of the proposal, and the testing team will provide the testing team with them.
So the AI systems are the most important aspect here. You could have designed similar hardware to this even a decade ago, but what's been missing are the brains and the control algorithms. So when we say that we trained the robot to walk in just 48 hours, what we actually did was we created this very high fidelity model of the robot, not just the surface level features, but also how do the individual actuators, the motors work themselves, what are the detailed dynamics of how those actually work, and you specify that very cleanly, and then you run massively in parallel, literally thousands of parallel simulations, where the robots are using something called reinforcement learning to try and learn how to walk, how to stay balanced, how to achieve these different activities that we've programmed them to achieve.
So can you run full body control? Can you run down again? Maybe back a little bit. Yeah. Let's do that. Let's start. Please do. I don't know. Yeah. Yeah.
So we could train only in sim, then deploy it onto the robot, and now the physical robot has learned in simulation, 10,000 plus years of walking just in those 2 calendar days that was then transferred to the robot. So this is how we got the robot walking so quickly, and this is a different paradigm than where these robots were, in the past decade. Once you know how to control all the joints in the system, there's a higher level AI brain. We have the kinetic AI system, which is our AI brain that runs on all the different robots, and that's the one that learns from these data demonstrations and commands the whole body controller to control all the joints to accomplish whatever task we need to accomplish, whether that's doing machine feeding or picking totes or moving fenders in an automotive factory. Basically, if you can demonstrate to the robot how to perform this task yourself, then the robot can learn how to perform that task. This is basically the big unlock that makes this a commercially viable system.